In this video, we are going to learn about the queue data structure. So first of all, we are going to see about the QADT. The principle behind the queue is FIFO, first in, first out. The queue word is very familiar to all of us because wherever we go, we'll see, like the queues actually, the people standing in a line. So when you are going for ticket booking, whether it is a theater, bus station, railway station, then checking into the airport, immigration time, any many places we will see this. And obviously, the principle behind that is FIFO, that is first in, first out. No, like who enters a queue first will be coming out of the queue first, right? So the same basic principle we are following here also. So it is very easy to understand because it is very much related to our general life. So what are the operations we are having in the queue is NQ. NQ is nothing but like inserting an element into the queue. So this adds an element to the queue, and here end of the queue we are going to add an element, and then DQ, removal of the elements we are going to do. Peak or front means we are going to see the element available at the front end of the queue without deleting it. So you can see whatever the element is at the front end of the queue, and the element you are going to view only, it will not be deleting from the queue. And rear is like this operation returns the element at the rear end without removing it. So if you observe in the previous videos of the stack, peak operation is there, which returns the top of the stack element, but it will not delete from the stack actually. So here, because we are having in both the directions, two pointers will be there, front and rear, we can say. So in the case of stack, we are having only the top of the stack, single pointer, but here we are having two things like a front and rear actually. So if you want to verify the element at the front end, you will use front operation or peak function. If you want to verify the element which is at the rear end, you can go with the rear function actually. Is full, is null. So is, instead of going for is empty, we are going with is null actually. So is full is, if Q is full, we are going to have the is full function returns true, otherwise it returns false. If it is null, then it is returns true, otherwise it is false. Okay, so this is how we are going to have, and enqueuing means you are going to insert elements in from this end, and you are going to delete the elements from this end actually. Okay, so this is a QADT. And we are having different types of queues actually. So the different types of queues are simple queue, circular queue, priority queue, double-ended queue, input restricted queue, output restricted queue. And in the case of priority queue, we can have both the ways, that is ascending and descending order priority queues. So let us see what is what actually. So simple queue is, as we have seen in the case of QADT, only one end we are going to insert the elements and the other end we are going to delete the elements. So this is simple queue. So in this type of queue, the input can be taken from only one end and deletion can be done from the other end. So no, like enqueuing we are seeing, and dequeuing can be done from the other end actually. And input restricted queue. So this is a simple queue. In this type of queue, the input can be taken from only one end, but deletion can be done from any of the ends. Means from both the sides, you can delete the element, but only from one end you can insert the elements. Output restricted queue means from both the sides, you will be able to insert the element, but deletion can be done only from the one end actually. Circular queue. This is a special type of queue actually, where the last position is connected back to the first position. Like cycle it will be, okay? And here also the operations are performed in the FIFO order. Means like first in, first out principle only will be followed even in the case of circular queue. Then comes double-ended queue. In a double-ended queue, the insertion and deletion operations both can be performed from both ends. So, In the case of simple queue, you are doing only from one end insertion and the other end deletion. And but in the case of double-ended queue, from both the sides you will be able to do insertion, and from both the sides you will be able to perform deletion actually. Then comes priority queue. A priority queue is a special queue where the elements are accessed based on the priority assigned to them. So for each and every elements, we are going to have a priority assigned actually, and using that, we are going to access that particular elements. So that is priority queue. Don't worry, we will see the process of each and every queue in detail.